Hello and welcome to the Night Sky in a Telescope, a YouTube channel devoted to helping you explore the night sky. This month, Jupiter and Saturn are disappearing from view but are briefly joined by Mercury in the evening twilight. The Quadrantid meteor shower puts on a show on the evening of the 2nd and the early hours of the 3rd, while the Orion Nebula is an ideal target for beginners throughout the entire month. Jupiter and Saturn are both almost lost from view, but you might still be able to spot them low over the southwestern horizon after sunset. After passing Saturn on December 21st, Jupiter is 1¼ degrees on the 1st, with that gap increasing to nearly 3 degrees by the 15th, and 4¾ degrees by the end of the month. This means they'll remain within the same binocular field of view until they disappear from view. The pair will set about an hour and a half after the Sun on the 1st, but will only be visible for the first half of January. Saturn will be in conjunction with the Sun on the 23rd, with Jupiter following on the 28th. If you've never seen Mercury before, you could get your chance this month. It will edge away from the Sun and into the evening sky during the first week of January. You can catch it very low in the southwest from about the 5th onwards. Look for it just below Saturn on the 8th, directly below Jupiter and to the lower left of Saturn on the 9th, and then forming a triangle with the planets on the 10th. It will then continue to move away from the pair over the next few nights, with the crescent moon in line with the planets on the 14th. Mercury starts the month at magnitude -0.9, with a disk that's 4.8 arcseconds in diameter and 98% illuminated. Its apparent diameter will increase to 5.7 arcseconds by the 15th, and its disk will be 82% illuminated, but its magnitude will remain the same. It will fade to magnitude 1.0 by the 31st, with a disk that's 8.7 arcseconds in diameter, but only 19% illuminated. Time is running out if you want to see Neptune. At a relatively faint magnitude 7.9, you will need to wait for the skies to properly darken and then use binoculars to locate it. You'll find it fairly low over the west-southwestern horizon, giving you a small window of opportunity to spot it before it disappears from view. Mars remains an easy target throughout January. It's visible high above the southern horizon after sunset on the 1st, and will set around 2 AM on that date. It will set about an hour earlier by the end of the month. It will also fade and appear to shrink a little during January. It starts at 10.3 arcseconds in apparent diameter and magnitude -0.2, and it will finish at magnitude 0.5 and 7.8 arcseconds in diameter. Lastly, it will cross the border from Pisces to Aries on the 4th. After moving into Aries, Mars spends most of the month close to Uranus, with both planets fitting within the same binocular field of view from the 8th to the 31st. The pair will be at their closest on the 20th, when about 1.5 degrees will separate them. This is also when the moon will appear just below the pair. Since there are no other bright stars nearby, this makes it the perfect time to spot the 7th planet. It'll appear as a pale, bluish magnitude 5.8 star through binoculars, but a small telescope will reveal a tiny disk. Lastly, we come to Venus in the pre-dawn sky. It rises about an hour and a half before the Sun on the 1st and appears as a brilliant white star above the southeastern horizon. However, like Jupiter and Saturn, it will disappear within the Sun's glare by the end of the month. If you have a clear view of the horizon, you might still be able to catch a final glimpse of it around the 20th. Venus remains a steady magnitude -3.9 and 10 arcseconds in apparent diameter throughout the month, while its illumination will increase slightly from 95% on the 1st to 98% on the 31st. In terms of constellations, the planet starts the month in Ophiuchus and then moves into Sagittarius on the 5th. Look out for the waning crescent moon some way to its upper right on the 10th. The super slim moon will then appear beside it the following morning. In terms of the moon itself, it reaches last quarter on the 6th before turning new on the 13th. First quarter is a week later on the 20th, and then the first full moon of the new year occurs on the 28th. If you missed the fireworks on New Year's Eve, you might get a second chance in the early hours of January 3rd. The Quadrantid meteor shower originates from an area of the sky within the constellation of Boötes the Herdsman. They're named the Quadrantids because they were identified when an old constellation, Quadrans Muralis, was still in existence. The Quadrantids have been known to produce 50 to 100 meteors an hour, but more realistically, you could expect to see about half that under ideal conditions. There's also a waning gibbous moon that night, which will brighten the sky and make it hard to see the fainter shooting stars. It's not all doom and gloom though. The shower can produce some fireballs, so if you want to try your luck, you really have two options. Wait until the early hours of the morning, when Boötes will itself be rising, or go outside on the evening of the 2nd before the moon rises at around 10 PM. If you're looking for something easy to see in the night sky this month, you could always take a look at the Orion Nebula. Orion is visible throughout the night and is due south at 11 PM on the 1st, 10 PM on the 15th, and 9 PM on the 31st. You can find the nebula below the 3 stars of Orion's belt, and it's bright enough to be visible to the naked eye, even from suburban skies. Binoculars will show a small misty patch, with a couple of tiny stars visible in the center. These stars are part of a star cluster known as the Trapezium, a group of small stars that are actually being born within the nebula. You'll get a better view through a telescope, with even a lower magnification providing a spectacular view. You should easily be able to see the 4 brightest stars of the Trapezium and some subtle markings within the nebula itself. Nebulae are huge clouds of gas and dust in space, where stars are born before they drift out into the cosmos. The Sun itself was born in a nebula like this, some 4.6 billion years ago. The Orion Nebula is thought to be some 1,400 light-years away and nearly 35 light-years in diameter. This NASA video visualizes a flight through a 3D model of the Orion Nebula and is based on visible light observations from the Hubble Space Telescope. That's it for this month. If you liked the video, hit the subscribe button and feel free to comment below. If you're interested in my books, you can find them at tinyurl.com/rjbamazon-us. And if you'd like to come join the Stars and Stuff Facebook group, you can find it at tinyurl.com/SNS Facebook group. Lastly, you're more than welcome to email me at astronomywriter@gmail.com with any questions you might have. Thanks for watching, and until we meet again, clear skies to you.